Now we can finally start rendering. If you only needed a single image, you could go to Render, Render Image, or simply press F12. That would give you one fully rendered frame, which you could then save manually. But in our case, we're creating an animation. That means we need every frame, not just one. So instead of Render Image, we'll use Render Animation. When you render an animation, Blender calculates each frame one by one and automatically saves them to the output folder you defined in the output settings. You don't have to save anything manually. Blender takes care of that for you. Now, when you look at the file format options, it's tempting to think, I want a video, so I should choose a movie format. That sounds reasonable. But in practice, it's not the safest workflow. Rendering directly to a movie file can be risky. If Blender crashes, if the system shuts down, or if the render is interrupted halfway through, everything is lost. All that time, gone. And with longer renders, this happens more often than most people expect. That's why, for animation work, it's always safer to render an image sequence. Each frame is saved as its own individual image file. So if something goes wrong, you don't lose everything. You simply continue rendering from the last completed frame. It's safer, it's more flexible, and it gives you more control later in post-processing if you ever need it. For most projects, PNG works perfectly well. If you want slightly higher robustness, TIFF is also a great option. You'll also notice options for 8-bit and 16-bit color depth. 16-bit stores more color information and gives you more flexibility in color grading, but it also creates much larger files. For this project, 8-bit is more than enough. Once your output folder is set and your file format is selected, the render setup is ready. All that's left is to choose Render, Render Animation, and let Blender generate the sequence. But before committing to the full render, it's always a good habit to pause here for a moment and run a quick test. Rendering a single frame, or even a short range of frames at lower samples, can save you a lot of trouble later. It gives you a chance to catch issues early, before you spend hours, sometimes days, rendering the full sequence. This step becomes especially important for longer animations. Small problems often hide until the render is already underway, and a quick test render helps prevent that. So take a moment here and inspect the scene carefully. It's one of those steps that doesn't feel exciting, but it can save a huge amount of time later. One of the first things we should verify is face orientation. Switch your workspace to Layout. While you're in Solid View, open Viewport Overlays and enable Face Orientation. As soon as you activate this option, Blender shows the direction each face is pointing. Blue faces are correct, they face outward. Red faces indicate flipped normals, the face is pointing inward. At first, this might seem like a small detail, but it matters more than many beginners realize. Shaders, lighting, and even the camera all expect surfaces to face outward. When normals are flipped, light behaves incorrectly. Materials may look broken, and during rendering, strange artifacts can appear, often much later when they're harder to trace. So if you see red faces, never ignore them. Pay special attention to the inner cube in our scene. Remember, we created that cube while the camera was outside of it, which means the camera expects the cube's outer faces, not the inner ones. If you find flipped faces, switch to Edit mode. Select everything by pressing A, then press Shift-N to recalculate normals. In most cases, that fixes the issue immediately. If it doesn't, which can happen with enclosed or layered geometry like our cube, open the Recalculate Normals options and enable Inside. This tells Blender to orient the normals inward, which often resolves issues for interior meshes. When you're finished, take one more careful look. Everything should now appear correct. Once that's confirmed, you can move forward with confidence, knowing the geometry is clean and the render won't produce avoidable shading issues later. Next, let's check for objects that should not appear in the final render. In this scene, we still have the individual sprinkle objects. These exist because the geometry node system uses them as references, but we don't want them to render individually. Here's the clean solution. Open the outliner, find the sprinkles collection, then disable the camera icon for that collection. This keeps the sprinkles visible in the viewport so you can continue working, but prevents them from appearing in the final render. And importantly, it doesn't break the geometry node system. Everything continues working exactly as expected. Now remember earlier we used a random value node for sprinkle scale and rotation inside geometry nodes. When rendering a single image, you won't notice any issue. But during animation, Blender recalculates the random value for every frame. That means the sprinkles would change rotation and scale continuously from frame to frame, which obviously isn't realistic. In the real world, sprinkles don't shift or rotate as the camera moves. They stay fixed in place. So to fix this, we need to apply the geometry nodes modifier. But before doing that, there's one more small issue to address. While preparing this section, I noticed that some sprinkles slightly intersect the icing mesh. A few even sink through the glaze and touch the donut surface. In a still render, this might look harmless, but in animation, overlapping geometry can cause shimmering or flickering, a very common artifact when two surfaces occupy the same space. Even if it's barely noticeable in a still image, once the camera moves, it becomes distracting. So first we'll fix that. We'll add a small offset to lift the sprinkles slightly above the glaze. Go to the Geometry Nodes workspace, press Shift-A and add Set Position. Place it between Distribute Points on Faces and Instance on Points. Now drag from the normal output of Distribute Points on Faces. Add a Vector Math Scale node. Then connect its vector output to the offset input of Set Position. You'll notice the sprinkles immediately start floating above the surface. That's because the default scale value is 1, which is far too large. So reduce the scale value to 0.005. This lifts each sprinkle slightly along the surface normal, just enough to prevent intersection. Next, go to the Rotate Instances node. Set the pivot values to 0. This ensures that each sprinkle rotates around its own center. Now return to the Layout workspace. Apply all modifiers for the chocolate glaze, just like we did earlier. Then either apply or remove the Geometry Nodes modifier for the sugar glaze. At this point, what we want is a final, clean, production-ready donut. And now, it's ready. The next thing to check is object intersection and positioning. Even very small overlaps can become noticeable once the camera starts moving. In a still viewport, tiny intersections can easily go unnoticed, but in animation, especially when reflections and shadows interact across glossy surfaces, those overlaps become distracting. So if the donuts are touching or intersecting, adjust them slightly. Now I might rotate the chocolate donut slightly along the x-axis. Right now it's tilted a bit to one side. If I orbit around the scene, you can see the donut slightly intersecting the plate's edge, so I'll rotate it along the y-axis, very gently. Alright, let me go back to camera view. I may move it slightly toward the center, like that. Maybe adjust this one too. Let's check again. It's still intersecting the plate, so I'll rotate it just a bit more, carefully, and maybe lift it slightly upward, just enough so it rests naturally without cutting into the plate. Yeah, that looks much better. In your scene, if the plate and coffee mug are sitting too close together, just give them a little more space. Each object should maintain a small gap while still feeling like part of the same composition. Take a moment to adjust things until the camera captures a clean hero view of the scene. Now, let's carefully examine lighting and exposure. This is one of those quiet steps that can completely change how realistic a render feels. Go to Color Management and temporarily change the view transform from filmic to false color. False color isn't meant for beauty. It's a diagnostic tool. It reveals something that is often difficult to judge just by looking at a render. how exposure is distributed across the image. Most of the time, evaluating lighting directly from the rendered view is surprisingly difficult. Even when a scene looks good, it's not always obvious whether the lighting is actually balanced. And this becomes even harder when you're still developing your lighting intuition. You place a few lights, maybe a directional light, an area light, sometimes an environment light. Then you render the scene, and you think, looks good. But looking good isn't the same as being balanced, and it isn't the same as being technically correct. Until you build lighting sensitivity over time, it's very hard to evaluate light purely by eye, especially from a rendered image, because the eye adapts. Your brain quietly compensates for brightness and contrast. So if you're new to lighting, if you don't yet have a strong understanding of light behavior, or you're not deeply familiar with color science, how do you analyze your lighting technically, not just visually? That's the real question. And the practical answer is very simple. We use false color. False color converts exposure values into colors. It removes the beauty of the image and shows the raw exposure distribution instead. Now you'll see different colors across the image. Each color represents a different exposure range. Yellow indicates mid to high exposure. This is generally a healthy range for well-lit surfaces. Red or orange indicates very bright areas. These regions are approaching clipping. Green or cyan represents midtones or properly exposed shadow regions. Blue indicates darker shadow areas. Now, before adjusting anything, just observe. Don't change the exposure yet. Right now, I'm simply demonstrating how to read the image. Pay close attention to white areas. White is critical. White means clipped highlights. It means there is no data left there, no texture, no surface detail. That part of the image will render as flat white. And most of the time, we want to avoid that. Now look at red areas. Red indicates strong brightness. It's not clipped yet, but it's getting very close. A few small red areas are acceptable, especially on strong specular highlights. But red should never dominate the scene. If you start seeing white regions or red spreading across entire surfaces, then you slightly reduce light intensity or lower the exposure. Just enough for the white areas to disappear and for the red regions to become controlled. Once you learn to read false color, you stop guessing. You stop relying entirely on your eyes. Instead, you start making lighting decisions with confidence. And that's how your lighting skills improve much faster. Not by adding more lights, but by understanding what your light is actually doing. Now, pay attention to how exposure is distributed. This scene actually contains 3 very different material behaviors, and each one responds to light in a completely different way. That's where lighting becomes more challenging. First, the marble plane. In real life, marble is bright, crystalline, and reflective. This surface doesn't just receive light, it reflects a large portion of it back, which means it's extremely sensitive to brightness. If the light becomes slightly too strong, the surface begins to clip. Details disappear. The texture fades into brightness. So a strong directional light isn't always ideal for marble. To preserve detail, we usually rely on soft area lighting. Second, the sugar glaze. This material is translucent and glossy. Light enters the surface, travels through it, scatters slightly, and then exits again. To support that behavior, the glaze benefits from 2 qualities of light. First, a physical directional light, strong enough to pass through the glaze and create depth. Our cycle sunlight handles that transmission. But we also benefit from a softer secondary light. That second light helps maintain the smooth highlight across the outer surface. Third, the chocolate glaze. Chocolate behaves very differently. It's darker, thicker, and largely opaque. When light hits chocolate, much of the energy is absorbed instead of reflected. So instead of sharp reflections, we see soft diffusion. The lighting setup that works for marble will also work well for objects like the coffee mug and plate. They behave similarly under light, so we don't need to treat them separately. But now, all three materials exist in the same scene. And that's where the challenge appears. The light setup that works for marble doesn't necessarily work for sugar glaze. The lighting that preserves chocolate may not work well for marble. Each material responds differently, so the question becomes, can one global light setup solve everything? The answer is no, because global lighting treats every surface the same. But these materials do not respond the same way, so we need another approach. Instead of relying only on global lighting, we sometimes adjust how specific lights influence specific objects. In other words, we control how light interacts with different materials. At first, that idea might sound strange. How can one scene contain different lighting behavior for different objects? But it's absolutely possible, and in a moment, I will show you exactly how it works. Before we do that, let's observe a few problems that are already happening in our scene. First, look again at the marble plane. It's becoming too bright across large areas. Meanwhile, the objects sitting on top of it are not equally bright. This isn't because the light is necessarily too strong. It's because marble itself is very sensitive to light. Your first instinct might be to lower the exposure. Technically, that would reduce the brightness, but the moment you reduce exposure, everything else in the scene also becomes darker. Why? Because the lighting we're using right now is global. Any adjustment affects the entire image equally, and that's the limitation we're dealing with. Second, look at this deeper shadow area here. Imagine if the chocolate donut were replaced with a lighter object, something like ceramic. That shadow would feel perfectly normal. But chocolate is already dark brown, so when a shadow falls on it, the surface becomes too dark. Look closely. It almost turns completely black. And when a surface falls into that range, the chocolate loses detail. So this is another problem we need to correct. Third, look at the rim edge of the sugar glaze. Instead of staying reflective and translucent, the rim begins to look a little harsh. You can see a strong edge shadow forming there. Why does this happen? Because the chocolate glaze absorbs most of the incoming light. Very little of that light is reflected back toward the sugar glaze. In the real world, objects illuminate each other through indirect reflection. That surrounding light is what helps glaze maintain its transparency from different viewing angles. But in this scene, the chocolate is absorbing most of the light energy. Almost nothing is bouncing back. So the sugar glaze loses that environmental reflection, and the rim starts to look harsher than it should. So now we have three clear issues. The marble is too bright, the chocolate shadow becomes too dark, and the sugar glaze rim loses its natural reflection. And somehow, we need to correct all three. Most of the time, artists rely on global lighting, light that affects every object equally. That approach works beautifully when materials behave similarly under light. If everything reflects and absorbs light in a comparable way, global lighting works perfectly. But when objects respond very differently, like in our scene, we introduce local lighting. Lighting that affects only the objects we choose. So we keep the global light and carefully mix it with local light. That balance is what gives us professional lighting control. First, let's create a new collection for the objects we want to treat separately. Select the sugar glaze. Then, select the chocolate glaze. Press M. Create a new collection. Name it something like Sun Affected. Now select the sunlight. Go to Object Properties, the orange square icon. Expand the shading section and find Light Linking. Here we can link the sunlight only to the objects we want it to affect. Click the drop-down next to the collection icon and choose the collection we just created. You can enable or disable objects individually. Since we want strong highlights on the glaze, keep both glaze objects enabled. Then click Make Single User. Good. Now, let's observe the result. Only the glaze objects are influenced by the sunlight. Their lighting remains consistent, but the countertop, the coffee mug, and the plate, they are no longer affected by that direct sunlight. In a normal rendered view, the difference may be subtle, but if you switch back to false color, the difference becomes very clear. We've prevented the sunlight from over-brightening the countertop, the plate, and the coffee mug. That was the goal. Whatever brightness remains now comes from the general scene lighting. Later, we'll slightly reduce the sunlight strength. Now let's move back to the glaze lighting. Before adding anything new, I want to clarify something. We're about to introduce a fourth light, and I don't want this to be misunderstood. In most scenes, 3 lights are more than enough. For the majority of 3D work, that's the ideal setup. However, when a scene becomes slightly more complex, we may introduce a fourth light to solve a specific problem. But in general, you should avoid going beyond 4. Whenever possible, try to solve lighting problems using 3 lights or fewer. Instead of adding new lights immediately, focus on improving how the existing lights work together. Because once too many lights enter the scene, surfaces start to flatten. Materials lose depth, shadows lose meaning. Instead of realistic surfaces, you end up with something artificial. Lighting determines how every object appears. If lighting is incorrect, shape and material both suffer. Details disappear. So treat lighting carefully. Now, for the dark shadow on the chocolate glaze and the harsh rim shadow on the sugar glaze, we'll introduce one small area light. Both issues come from the same cause: directional light without supporting bounce light. Sugar glaze is extremely sensitive to directional light, especially along the edges opposite the main light source, where the sunlight doesn't directly reach, and where there's no surrounding reflection. The glaze falls into shadow too quickly. So what do we need? A soft fill light placed opposite the sunlight. First, move the 3D cursor to the side. Press Shift-A, Light, Area Light. Now rotate it along the Y-axis. Press R, then Y, and rotate to -90 degrees. Scale the light up. Roughly match the size of the plate. Then move it upward. Bring it closer to the donut. Rotate it again slightly along the Y-axis so the light points downward toward the donut. Yes, like that. Now move it along the X-axis, placing it quite close to the donut. It can even move slightly toward the center. The light should remain close enough that the chocolate surface absorbs most of the light. Now let's adjust the light settings. Open the light properties. Set power to 100. Set exposure to 1.5. Enable temperature. Set it to 3000. We don't want a neutral white light here. It should harmonize with the sunlight. Slightly warm. By the way, if these values work for you, that's great. If not, try adjusting them slightly and observe the result. That's one of the best ways to learn lighting, not by copying numbers, but by changing them and watching what happens. While preparing this tutorial, I experimented with these values quite a bit. That's part of the process. You might wonder why I'm not experimenting live on screen. The reason is simple. This tutorial follows a structured workflow. If we tested every value during recording, the lesson would become unnecessarily long. So I focus on explaining the technical structure, and I encourage you to explore the adjustments yourself. That's how real confidence develops. Now we need this area light to affect only the glaze, just like we did with the sunlight. Go to Object, Properties. Under Light Linking, choose the same sun-affected collection, then click Make Single User. Now I render the image again. You should notice a clear improvement. The heavy shadow that was sitting on the chocolate glaze is now lifted, and that harsh rim shadow on the sugar glaze has disappeared. Now everything behaves much more naturally. The objects still feel connected under the global lighting, but individually, each one receives the light support it needs. That balance is exactly what we're aiming for. Now, as you can see, the countertop is still slightly bright. Technically, we could solve that by lowering the sun strength, but instead, we'll adjust the scene composition. Because in 3D rendering, composition matters just as much as lighting and materials. Object placement shapes the visual story. Even though our scene represents a morning kitchen, we're not building the entire kitchen. We only need the small area where the donut is placed. So first, look at the empty space around the scene. Do we really need that much distance? Not really. Second, the countertop currently behaves as if it's sitting outdoors under strong midday sunlight, as if there were no ceiling, no walls, and unlimited light entering the room. We don't need that much light. Select the countertop. Then, Shift-select the backsplash and the cube. Press G, then Y, and move them closer to the donut. Like this, just a little closer. Now I notice something else. The backsplash and countertop are not snapping perfectly together. In your scene, they might be aligned already, but it's worth checking. This corner looks small now, but once it gets closer to the camera, it becomes noticeable. A small adjustment here prevents unnecessary distractions and keeps the viewer's focus on the donut. So I press G, then B, switch to vertex snapping, and snap the edges together precisely. Then I select the cube, press G, then B again, and snap it into position. Nice. Now nothing pulls attention away from the subject. Next, let's shape that early morning sunlight. A soft golden ray coming from the side, falling across the donut. Light doesn't depend only on strength, it also depends on how it enters the space. If the window opening is large, sunlight spreads as it enters. The light becomes softer and less directional. But if the opening is smaller, the rays enter more tightly, and that's when you get those beautiful, dense morning sun rays. Select the cube, enter Edit Mode, select this side edge, and move it along the Y-axis. Then, select the top edge and move it down slightly. That's enough. Now select this edge here and move it again along the Y-axis. Maybe just a little more. What we're aiming for is a condensed light ray. For that effect, we need a smaller window opening. Let's check it from the camera view. I will move this edge slightly upward. Now we're controlling the sunlight, so it mainly falls across the glaze. Its purpose is to support glaze transmission and enhance the subsurface scattering inside the donut. We don't want it hitting the marble directly. The marble will show its texture better under the area light. This is much better. But now, the room feels too dark. We tightened the sunlight so much that it only touches the donut, which was intentional. But in a real morning kitchen, the room would never become this dark. Even without electric lights, ambient light would still enter from outside. And this is exactly where our main area light becomes important. Select the large area light. Go to the light settings. Increase the power to 200. Then reduce the temperature to around 4,200, just enough to preserve that morning mood. Beautiful. Now the marble receives soft, delicate light that preserves its texture instead of washing it out. This area light now behaves like the room's ambient lamp. So now you can clearly see. Every light we added had a specific purpose. The cycle's physical sunlight for glazed transmission and donut subsurface scattering. The secondary sunlight for strong specular highlights on the glaze. The small area light to soften harsh shadows and recover chocolate detail. And the large area light to illuminate the room and reveal the marble texture. And remember, anything outside the camera frame doesn't matter. In 3D, everything is an illusion. We only make what the camera sees feel real. What exists outside the frame is irrelevant. No one will ever see it. And that illusion depends heavily on composition. Finally, go to World Properties. Reduce the sun elevation to 13 degrees. This creates a long, soft shadow across the scene. Then reduce the sun strength to about 0.3. Because we're now using 4 lights. If we kept it at 0.5, it would overpower the scene. That value works when sunlight is the only light source, but in this setup, it would break the balance. Now look at the result. The marble holds its texture and behaves like real kitchen marble. The sugar glaze remains glossy and slightly translucent, more natural, more appealing. The kind of glaze you'd expect on a premium donut under morning light. The chocolate glaze feels richer and creamier, and the donut itself looks freshly baked. That was the goal from the beginning of this tutorial, and now we've reached it. 2 donuts, sugar glaze and chocolate glaze, sitting beside a cup of hot coffee in a quiet morning kitchen. That's the story we built, and now the scene supports that story. This is our final exposure distribution. Everything is balanced. Nothing is overexposed. Nothing disappears into darkness. Earlier, we had 3 main lighting problems across 3 different materials, and we solved all of them by carefully combining global light and local light while adjusting the composition of the scene. So remember this, lighting isn't about making a scene bright, and it's definitely not about adding lights randomly. Without strong lighting, even strong materials will never look correct. You saw that clearly in this scene. The object stayed the same, the materials stayed the same, but once the lighting changed, the difference became huge. Lighting skill is essential. In real production, artists often spend far more time on lighting and materials than on modeling. Many models are imported, free or paid. You model only when necessary, but you constantly refine shaders, lighting, animation, compositing, and rendering. That's the real workflow of a 3D artist. Throughout this tutorial, I tried to keep everything clear and reproducible. We started with simple steps and gradually refined the scene piece by piece. That's why I kept the deeper lighting discussion until the end. The donut itself is simple, but the goal was never just the donut. After this tutorial, you'll build many different scenes with different materials and environments. So the real goal here was to introduce a production-style workflow. I structured this tutorial very similar to a full course. If this helped you learn something meaningful, consider subscribing to the channel and share it with others who want to learn 3D, freely and properly. Alright, one final check. Select the camera, then open Camera Data Properties. For a donut showcase like this, a focal length between 50 and 80 millimeters usually produces a clean product-style perspective. I believe we already touched on this earlier in the animation section, but let's quickly confirm it here. Set the focal length to around 65 millimeters. This gives us a perspective, close to how our eyes normally see food in real life. While we're here, you'll also see the option to enable depth of field. Depth of field allows the main subject to stay sharp, while surrounding elements gradually blur depending on the focus distance and the f-stop value you set here. This technique works especially well when you don't want every object in the scene to have the same level of sharpness. Background elements, like the backsplash in our scene, should remain slightly softer. We don't want them competing with the donut for attention. The donut is the hero object. When depth of field is first enabled, the image may appear blurry. That's normal. The camera simply doesn't know where to focus yet. Use the eyedropper tool, then click the object that should remain sharp, in our case, the sugar glaze. Now Blender knows exactly where the focus point should be. If the blur becomes too strong, slightly increase the f-stop value. This tightens the depth of field and restores clarity where needed. The result begins to feel much more cinematic, similar to how a real camera behaves. However, for this tutorial, I'll leave depth of field disabled, because we're rendering an animation, and during the animation the camera moves closer to the donut. If depth of field were active, the donut or the coffee mug could unintentionally drift out of focus, which isn't what we want here. Depth of field works best for still renders, where the camera remains fixed and the focus can be tuned very precisely.